Hey, John here. Last time I talked about the footprint on this. Look, that's garbage. Find a nice piece of landfill to call home. Here's the new version, Rev 1.1 of the Project 2067, a Z8S180 Breakout board. It has a header on this side that is designed to plug into this FPGA eval board I designed that has an ICE 40 FPGA on it, so we can see if we can use the FPGA in concert with Z8S180. As always, I want to thank my Patreons. You guys really help out, especially when I flub it. And I gotta order another version of the board here. So let's see if Rev 1.1 works out here. Let's put this thing together. Oh, not bad. The desiccants really work well. This has been open for several weeks, actually several months, probably last fall. It's mid-February right now. I think I opened this thing up, I got it in October, and I probably opened it up, when I was testing the design that I did before this was clearly 3-4 months ago. That's not bad. Of course, it's winter and the humidity's low. I'm just saying. All right, so I only got one of these. So it'd be nice if I don't manage to screw it up too bad. Let me get away with it flying here. So I got these big old white slugs here to mark pin 1. And this is reasonably marked on the package with a big old dot. Actually, it's got 2 dots, one there and one here. Now I got to look it up. It's probably this one there that has a little hole in it. But we want to make really sure we don't put this thing backwards. That will really, it'll be a bit of a drag. All right, so it looks like we got a dot, which we have 2 dots, but they say there's a dot, and then, there's a beveled corner here. So let's see if we can zoom way in on this thing here and have a look-see. There should be a beveled corner. Oh, that sort of looks better. Seriously, people that mark and label these things, they're such... Does it have to suck this much? I'm going to assume that's pin 1 here. If it turns into a space heater after you turn it on, it'll become more obvious that something has gone awry. Maybe there's something underneath here? No. What a no. People, must it suck this much? Idiots. Okay, moving right along. I don't know, YouTube, does that count as hate speech? I'll get blacklisted on a soldering video. Here we are. Alrighty, this one is only half as crappy as the last time I tried to do this. At least it fits this time. Alright. Alright, that looks pretty decent. And the pin spacing on this is more than their 0.5 millimeter super high density. So this should be easy to solder up, right? And famous last words, right? And we'll see how easy it really is once we fire up the iron and give this a nice eyeball here. Now we fit the static RAM on last time, and that looked okay. I think that's pin 1 there. We sit here admiring our work. They said is the right number of pins. Once in a while, I haven't managed to follow that up. That's always a good time. Always a good time. Oop, footprint problems are like a classic screw up. Even the professionals mess that up. They get too interested in everything else and you overlook like the most basic thing. Easy to get tricked up. All right, whatever. I test fitted this thing last time and it was fine. So let's get some flux on there. All right, here we go. A little bit of fluxage on there. It's a lot of fluxage. Just don't put too little on there. You will have trouble if you don't have enough. That is a ton. Maybe I'm out of practice. It's been a while. It just occurred to me just this moment. This is the first project, a soldering project I've done in my new shop here after moving. So let's see how this goes. Am I jinxed or is all gonna be well? Stay tuned. That question and more will be answered. So what do we got here? All right. Of course, this flux is like white and gooey. I can't see the socket. I can't see the the footprints. Oh boy. All right. I may have to zoom the camera in, or I might just grab a magnifying glass here. Get my trusty Magno glass out here. Oh yeah, this is working for me. Okay. That looks close enough. This one I can't tell. What usually happens is as soon as you touch the iron in there, this stuff melts really quickly, and then you can get really clear on there and you can see what's going on. I want to make sure I can tap the kitty corners. Yeah, this actually looks pretty darn good. Shockingly okay. Wow. All right, let's tap in some corners and review it. I'm having a hard time seeing in here. Let's zoom in some more. Use this as my bench scope while I'm soldering. There we go. All right, that's not too bad. Ooh, the whole thing needs to be a slight nudge over this way. Ooh, a little too much. Nah, it's okay. That looks good. This, I can't really tell. Yeah, actually it looks fine. Okay. Alrighty then. Let's get some solder on here and dab it on there. Well, the one thing I can say about my new workspace is that the lighting looks better for the video, but it's terrible for me while I'm sitting here. Yikes. Let me bring another light up here. All right. I think I'm due for another visit to the old optometrist is what I am. All right, there's a quarter pin. There we go. He's definitely on. Complete with a solder bridge. You know, you can't move forward until you get a good bridge in there and create a real problem, you know. And I definitely want to get the exhaust fan going in here. Whew, this flux. Not the same stuff I used to use. This is, I think I ran out or something, or I can't find it moving. Don't know where the other one is. I think this flux actually works better, but it smells worse. Isn't that always the case? It's either going to be more toxic or smelly or both is the case. It probably is. Oh, yeah, that's bad. Woo! Yeah, that's not going to be it. The fan is like right in the microphone. I have no idea if this is even going to be audible in any way. Yeah, I got to work out a few kinks in the old design here. All right, I think we're good. Let's go ahead and dab some more on here, just so mainly so we can see what's going on. Now usually, if you get the right amount of heat and the thermal relief is good, you can usually just kind of wand your way across the pins. And I really didn't quite do that, did I? Let's go back and heat that up a little bit. A little more solder on the old iron. Oh yeah, that's the stuff there. Alright, that looks pretty good. Let's take a look on the other side here. You don't want to get too many, you don't want to go all the way around. You want to just keep on, I'm doing the opposite corners and opposite sides in case you blew it, which is definitely something that I have experience with. Then you got to get out the air gun or something and heat up the whole thing, take it off, start over again. That happens, especially when you're learning. Alrighty, there we go. Well, that looks really good. Up, another bridge. Bridge over troubled waters there. I can't tell if there's solder in there. The amount of flux, all that fluid in there, creates the reflection. I can't see it, certainly not on the camera. Definitely my Wonder Bridge over here. Wipe the iron tip off, see if we can wick off some of the solder there. There you go, not too bad. Alrighty. Gotta love that. You know, this might be, you know, if you're gonna do surface mount, this might be a pretty reasonable way to start, because again, these pins are pretty far apart. They're not the 0.5 millimeter jobbies. Actually, you could say the SOIC, which is like 1.5 millimeter, 1.27 millimeters apart between each pin. Those are really far apart pins. It'll be like nice to see if this thing passes the smoke test here. That's the goal today. Well, maybe we'll slap together a quick test program. Maybe we'll clock the CPU and let it free run, executing no ops, and see it fetching instructions and selecting the memory and stuff like that. You should see the memory address just going crazy, counting up while it fetches one byte at a time, and incrementing the address and fetching the next byte and so on. That's the test I like to do on all my early designs. With a 68K, I did some some decades ago, the same thing. And 68Ks have like status pins. It's coming out the side that tells you, I am now fetching an upcode. I'm now fetching an upper end. I'm now doing this. And you can look at it all go by on your scope, and cool stuff happens, of course. Alrighty. Oh, there you go, baby. I'm low on the solder here. A little more solder juice on there. Ooh, a little too much excitement with the solder there. It's alright, you can kind of get rid of some of it that's on the tip by going over here, and then come back and pick up the, come on, here we go, kind of move it along. No bridges to see here, move it along, come on, let's go. Doesn't seem like it's heating up. Oh, I'll bet there's a ground pin on there with a lot of copper on the circuit board. I like to screw up my designs and not put a lot of thermal relief. Sometimes that can throw off your ability to solder. That has happened to me before. Alright, here we go. So you gotta kind of, when that happens, like one of these pins probably is a ground or something with a via really close. and it takes more heat on that one pin than all the others. Oh man, come on. It might be that both of these are grounded, and that's why that bridge won't go away. I'll have a closer look at the design files. It does look like that's the case. And I've wrestled with my own designs before, trying to get rid of a bridge and then find out later on that underneath the circuit board has a little copper trace between the two pins. Let's go have a look-see. Yes, indeedy. So these two pins are connected together anyway, so you don't have to care. But in reality, I don't know why I have such a nasty bridge in there in the first place. It is a thermal relief problem. Now, the more you mess with this, the more likely you are going to be to pull like the solder mask off the board. I mean, this is a really cheap board, and I'm not going to diss JL. These are from JLC PCB, but it's the cheapest thing they manufacture. So it's not going to be the highest quality, no matter what it is, right? So, So anyway, it would probably be ill-advised to mess with this too much, just to make it look nice. Because those two pins don't matter if there's a bridge. Every other pin does matter, like these over here. I think that's just light glare that makes it look like there's a bridge over there. The rest of these look like they're just fine and dandy. Fine and dandy. Okay. Really, I don't know. I really wish there wasn't a bridge in there. You should be able to get this out without resorting to the solder wick. I'm not a big wick guy. I don't use a lot of solder wick. In this case, it might help, but usually I can get the thing to do what I need to do by just heating it up nice. Now, before I get too far, I always like to take my 30X loop here and take a really close look. All right, well, other than that one bridge, that's pretty good. A bridge that I don't really think will make any difference. All right, let's put on those two capacitors there. All right, now to pass the smoke test, we don't even need capacitors. I can just power it up. I think we're going to be okay there. I got a bunch of 0.1s handy. I don't have any 1 micros lying on the bench here. Well, I'm going to just leave those off. We'll deal with it later. We'll put the 0.1s on. I mean, it'll run. Of course, if you leave these out, I mean, the more stuff you leave out, the whole point of these capacitors is for power filtering. And, they're necessary if the instantaneous current draw is really high and the chip and the power dips you'd have a problem with the chip is starved for enough power just for a short period. And, that can happen once in a while. Maybe never, right? But it can happen, and you got to be careful when you assess what you've accomplished. So if I leave one of them out and it acts wonky, it could be one of the suspects. You should maybe go back and put it in, is what I'm saying. But for a first pass, I'm not sure I care so much about it. I'm going to pre-solder these ends and put the part on there. Now I chose this end in particular because it has a lot of copper connecting to the ground plane, and it will sink a lot of heat, and it might be difficult to solder that end if you do that one second. But you do it first, get the whole iron in there, and maybe it'll be easier to heat up the pad. That has definitely happened to me in the past. With this end here, I don't know. Both of these really go to the power. And vias everywhere and everything else. But in any event. So the same thing over here, this pad here. If you pre-solder this one, you can see the big copper traces there. And there's big ones on this side. So I don't know, 6 of one, half a dozen out of the other. The one you really don't want to do, you see all the vias around this end here? Those vias move a lot of heat in the inside of the board. I tend to have a hard time heating those babies up if I do that one second with the component covering half of the pad. So, you know, this one here might be, this is going to give me a run for my money, for example. If I do this one second, because that via right there is going to sink all the heat out of there. So in this one, I'm going to pre-solder one of the pads. It should be this one. All right, that way at least I know that end will work, you know. So that looks pretty good. So the 0.1s, that's good enough. Of course, I can power it up until I put that connector on there. Now this connector has an unusual number of pins on it, even on the FPGA board that it plugs into. This is really multiple headers. There's actually a gap over here somewhere. So there's really just two headers stacked end to end and then stuck on there. So I have this header here, which is too big. I could put it on here. I could just put the thing on there and leave it too big and stick it off the end. But I'd rather not do that because I eventually will want to cut it off. So this is where it goes. I'm going to just be a slob, and I'm going to shear this sucker off with a side cutters like this. This may or may not be a good idea. I have a few spares. I'm just saying. If I can just kind of like, you know, I don't know. Maybe this is not a good idea. I'll cut a little long and then come back and clean it up maybe. Ooh. Well, hopefully I got the right number of pins still on there. The other ones are like falling all over the place. Okay. Alright, it's a little ugly, but I'll live with it. God darn, that was lucky. Let's mess with the end here. I probably shouldn't. I'm tempting fate, right? I think that's enough fate tempting for the for this slob job here. That actually looks okay, doesn't it? All right, don't it? All right, let's check a corner down. Probably help if I put a little bit of extra flux on there. Yeah, that doesn't even feel like it wants to go in there. This super tiny gauge solder here doesn't have a lot of flux inside it just because it's a tiny gauge. I should have used the bigger gauge. Let me clean off this iron tip here. And they got the fan going right here, which is also cooling things down with the wind blowing. Let's make sure it looks like it's in there and straight. Okay. Looks pretty good. I'm gonna dabble a little bit of this on here because that's, I don't know, it didn't seem right. Boy, that just doesn't want to go on there. Now these connectors were also incredibly cheap. This thing has got cheap written all over it. This whole board, it's the cheapest one they make. I bought the cheapest connector. Shear it off with the side cutters, and if this works, it'll be a miracle, people. I'm cutting a lot of corners here. Not always the best set of decisions right there, okay? I wonder if the iron's not hot enough. What do we got it set to here? I'm at 675 Fahrenheit. So I should have sound checked this thing. It probably sounds like a hurricane in here. Woo! The fan going like this. Come on, here we go. Anyway, so I just tipped up the old temperature by 20 degrees. I'm now running at 695 Fahrenheit, which is a wee bit toasty, but I think it's okay. What does everyone else use temperature-wise? I've always erred on the side of running the iron cool, because when I was a kid, I used to melt everything I was soldering and everything. So maybe it's still paranoid in the back of my mind, but it is annoying when it's not hot enough to get these things on there with all the copper and whatnot. These ground and the 3.3s, these got, I mean, front and back layer copper as well as the middle layers all sink in the heat while trying to solder these things. Again, you know, sometimes it helps if you put some flux on there. Honestly, I don't want to sit here and do all 60 pins or however many there are on this thing. I'll be here a month. I also don't want to clean all this mess up when I'm done. Alright, let's see here. Let's see if that helps. Okay, let's see y'all. Well, the solder's flying down these holes, but these just have one little teensy trace going to them, unlike the ground pins here and the power go to the inside planes. Just make sure you get it heated up enough, that's all. It might take a little longer. The iron on there a little longer to get the pad heated up. And I'm really kind of grinding it into the board. It's an exaggerated move. I'm kind of moving it around like that a little bit. And make sure that the iron is in contact with the pad copper, because there could be a little bit of oxidization in there acting as a thermal insulator, keeping the iron away from that copper, right? It's on there. This will probably go on in like no time at all. Don't even have any solder on the iron and it's going in good. Come on, get in there. Okay. All right, not bad at all. All right, going with no flux. We're going naked here. Solder naked. I mean, this is rosin core 6040 here. That's the other thing. So the temperature will change if you're using the rose clean stuff. All right, another round of flux cleaning. This looks okay. It really does. I wish I had a camera that worked a bit more closer to my eyes, especially after looking through here, because it looks a lot better up close, even with 30x magnification, than it does in the preview monitor here. I'm hoping the monitor's bad. Anyway, at this point, we can plug it in and try it out. when you do this. Okay, so there's no shroud here, right? So be very careful when you plug this in so you don't end up, off a couple of pins or a pin or something like that. It will fry the thing if you get the power on the wrong pins in any appreciable way. So look very closely, get the thing lined up just right. Right, there you go. See, that looks good, and it's on that way. And there, this looks pretty good, if not, even though it's out of focus. Okay. Fine. So next time what we'll do is we will write a really simple FPGA program so that whenever the read line is active, low, we will put a 0 on the data lines, no matter what the CPU wants, because we know that when it comes out of reset, when it's first powered up, it's starting to fetch instructions at address 0. And if we send it all binary zeros, it'll think it's a no-op, because that's a no-op for a Z80. And we'll just simply leave that as our first application. And what we'll see is that the Z80 will continue to fetch instructions and do a nothing, no op, and then fetch another, and so on. So what we'll see is on the address lines here, it'll just be counting, starting from 0, and then it'll go to address 1, address 2, continuously fetching no ops. And if that's the case, we know the board works. Of course, saying all this, there's more to it than that. We have to give it a clock. This has no oscillator on board. So what I'm going to do in the same FPGA program, I'm going to take the crystal oscillator here, and I'm going to, I don't remember, this one runs at like 25 megahertz or something like that. I'll just divide it by 2. Really simple FPGA Verilog program. Divide this by 2 and send it over here on the clock input so that it has a clock, so it'll run. You can also generate a reset and then take the reset off, and you can play around with some simple little programs, and you can use that to exercise the CPU, see if it's live. I've had multiple requests asking for more videos of free associating while soldering. So here you go. Here's one for you, people. Anyway, thanks for watching. I'll see you next time.